Hello, my name is Haziq and this is my EM3 assignment presentation.
So we're given this IVP or initial value problem that dy dx equals to x squared plus 1 over y, where y equals to 1 when x equals to 0 and y is greater than 0. So given this IVP, find the value of y when x equals to 1. Since we're given x, y, and dy dx, but we're not given the equation of the curve, we'll be using the Euler's method formula. And that formula says that yn plus 1 equals to yn plus h multiplied by fxn yn. And how this formula works is that fxn yn will be the gradient or the slope, aka dy dx that we're given, where h is the step size, aka how much we'll be increasing our value of x by each time. And since h is basically the change in x and dy dx is the change in y over the change in x, multiplying the change in y by the change of x with the change of x basically cancels out the change of x in the denominator, which leaves us with the change in y, which lets us add that to our yn to get the next estimated value of y, aka yn plus 1. So we're going to let our step size be h equals to 0.1 in this case. And in our case, our Euler's formula will look like yn plus 1 equals to yn plus 0.1, which is our step size, multiplied by x squared plus 1 over yn, which is our dy dx. Now we can write this into a table with 3 columns for x, y, and our dy dx, with our first row being 0 and 1 for x and y respectively, since that's the initial values we're given, and dy dx just being the value of the x squared plus 1 over y after we sub in the values of 0 and 1 into the equation. So as you can see in the x column, we'll be increasing the value of x by 0.1 each time until we get x equals to 1, which is what we're trying to find. And for our y, we'll just be using this Euler's formula.
As you can see in my spreadsheet over here, we will be using d2, which is the current value of y, plus 0.1, which is the step size, multiplied by d2, aka the dy dx formula over here. And we're going to be repeating that all the way until we hit x equals to 1, and that gives us 1.91138. As for the dy dx column, we'll just be subbing in the values for x squared plus 1 over y respectively. As you can see, a3, which is x squared plus 1 divided by b3, which is y. And that just repeats all the way until the last column respectively.
So that gives us 1.9114 for our Euler's formula. Then moving on to general solution, we know that dy dx equals to x squared plus 1 over y. So we multiply both sides by y, and then we integrate both sides, which lets the dx be cancelled out on the left side. And after integrating everything, we multiply everything by 2, and then square root it. Now we can sub in the value of y equals to 1 when x equals to 0, and that gives us c equals to 1. So our general solution is yx equals to square root 2/3 x cubed plus 2x plus 1. Now subbing in the values of x equals to 1 into the equation to find y, we get square root 11 over 3, and that gives us 1.9150. Now to find the approximate error in our working, we take the general solutions formula minus the value of y that we got from the Euler formula, and that gives us 0.0036, which tells us that our Euler formula was successful since the margin of error was quite small.
And that's all from me. Thank you.